In this HtDF example problem, you're going to see a case where the problem statement isn't very specific about the function we need to design. That's going to happen more and more as we go forward in the course. Remember what I said in the first video. Design is the process of going from a poorly formed problem to a well-structured solution. So making the problem more specific is part of the design process. In this video, I'm also going to talk about how many tests you need for a function. And we'll see another example of a case where you get partway through the recipe and realize that you need to go back and refine some work that you did in an earlier step of the recipe. In this problem, we're asked to design a function that consumes an image and determines whether the image is tall. So let's see. It seems clear that it consumes an image. But what does it mean to determine whether the image is tall? Well, we're asking, is this image tall? So that's kind of a yes-no question. By convention, whenever we design a function that produces the answer to a yes, no, or true-false question, we design that function to produce a Boolean. So we'll say Boolean here. Okay? And now what's the purpose going to be? The purpose is going to be something about if the image is tall. And the key thing is, so far I've only said it produces a Boolean, but I haven't said what true means. So you want to say in the purpose, produce true if the image is tall. You need to distinguish which does true mean. Does true mean that it's tall or that it's not tall? So whenever you got a function producing a Boolean, your purpose has to be very clear about what true means and, by implication, what false means. So let's see, here's a stub, and this didn't tell us what name of a function to use. The problem statement didn't tell us what name to use. That's usually going to be the case. You're usually going to have to invent the name of a function when you design it. And it turns out that in the programming language we're using, there's a convention that functions that produce a Boolean, functions that produce an answer to a yes-no question or a true-false question, have a name that ends in question mark. So we're going to call this function tall question mark. It's going to consume image, and a good dummy answer is false. So that would be the stub, and now we can write some tests. So let's see, check, expect, tall question mark. Let's see, I need an image, so let's take a rectangle. Oh, wait a minute, before I forget here, I'm using rectangle. So let me quickly go up top here and say require to HTTP/image. So I'm going to make a rectangle that, let's say, is 2 wide and 3 high and is red. The color doesn't really matter here, but rectangle needs the arguments. Let's see, it seems to me that a rectangle that's 3 high and 2 wide is tall, so we'll say true. Now I want you to ask yourself right now, how many tests does this function need? The right number of tests for a function is going to be an issue that we talk about more and more during the course. How many do you think this function needs? Write down your answer, or just remember it, and we'll see where we end up. For now, I'm just going to kind of assume that it only needs this one test. That won't turn out to be right, but we'll see what happens. Let me run the tests, and there's one test, and it runs and fails, so it's well formed, so we can keep going. Let's see, this is the stub. We'll comment it out. We'll write the template. The template is tall question mark img ... img. We'll make a copy of that. And we'll comment out the original template. We'll label it as the template. Now let's see, what does it mean? The function, let's see, these functions have two cases, right? Sometimes it's tall and sometimes it's not tall. So when you have two cases, you can use an if, because there'd be the case where it is tall and the case where it isn't. And what I like to do whenever I add an if to my template is I put in the if, and then I make myself 3 copies of the rest of the template as a way of saying, okay, now I've got the if in there and I need to decide what happens here. Now let's see. Tall involves comparing the width to the height. So let's see. If the image height of the image is greater than the image width of the image, well, let's see, if that's true, then the image is tall, and so I should produce true. And otherwise, I should produce false. Well, let's try running that. Okay, the test passed. The test passed, but are we done? Have we really tested this function? Well, one clue that we haven't, Dr. Racket is giving us right here in the way it's colored this false. Depending on how you have your Dr. Racket configured, it might actually just highlight this false with black. But in both cases, what it's saying is it's saying, hey, this expression here was never evaluated. There's this concept called code coverage for a test, or test coverage, which says, given all my tests, how much of the code is actually being evaluated? And if the answer is not all of the code, then you don't have enough tests, because what if the piece of code that isn't evaluated is wrong? You haven't tested that piece of code. So whenever you run your tests, if you see code that's highlighted that says that it didn't get evaluated, then you know for sure you need more tests. And what's happening, of course, in this case is we tested the case where it is tall, but we didn't test the case where it isn't tall. In this case, we can do that fairly straightforwardly by copying the first test and just swapping these two around and saying, well, in that case, it's false. Now let's run it. Both tests pass. But are we really done? Let me make this a little bit, give us a bit more room here. Are we really done? At this point, what you might think of is, hey, wait a minute. There's one more case. What if it's the image width and the height are the same? What should happen then? And this is a thing that happens in function and program design all the time. You realize partway through the design process that there's a boundary condition, or sometimes we call it a corner case, that you hadn't quite thought of. It's perfectly fine for that to happen, but when it happens, when you say to yourself, wait a minute, what if the width and height are the same? You need to immediately do a couple things. First, write an example for it. Then decide what the behavior is. And I'm going to decide in this case that if your width and height are the same, you're not tall. So write the example, write the expected result, fix the purpose. Height is greater than width. So that it's unambiguous in the purpose. And if what you decided required you to change the function, change the function. In this case, it didn't. But if I had decided this the other way, I would have to change that to a greater than or equal. And now run the tests again. Now all 3 tests are passing. So that's the design of that function. That works. When I run it and the tests pass, all my code is evaluated. So I've got good test coverage. So I'm pretty good here. At this point, I just want to make one minor detailed point, which is whenever you have an expression of the form if something, true, false, you can always replace that by just this simpler thing. Let me comment this one out. Racket comment out with semicolons. Why are these two the same? Well, look, this one says if this expression evaluates to true, then produce true. Otherwise, if this expression evaluates to false, then produce false. So that's really just the same as the expression itself. Either this expression evaluates to true or it evaluates to false. So whenever you have if something true, false, you can just replace it with the question itself. And in a normal program, once you've done something like that, you would clean this up. You delete that out from there. And in a couple weeks, you also won't leave the stub and template behind. So now you've seen the How to Design Functions recipe, and you've seen me work through 4 examples of it, where each example showed some more wrinkles to the process. What you should do now is go work through all the practice problems for this week, and then do the homework problems and the quiz. Let me stress something about this material. I just can't make this point strongly enough. This is the kind of material that you learn by doing. I really want to encourage you, don't look at the problem and then look at the solution. If you do that, you're going to say to yourself, oh, I know how to do this. You need to actually take the blank starter file and work through the problem yourself from beginning to end. That's the only way to learn this kind of material. At any rate, have fun with the practice problems and the homework, and I'll see you next week.